Hello and welcome to Unit 9, Part 3. My name is Mr. Bell, and today we're going to talk about vertex form, and we're also going to do some converting from vertex form into standard form. On this slide, it says to identify the vertex and axis of symmetry of the following quadratic functions. Well, these two functions could be graphed, and you could get that information that you needed. Or sometimes quadratics can be put in or are already in something called vertex form. So let me show you that down on the bottom in green before we actually work out these examples. So this is vertex form. So y equals a times x minus h squared plus k, where h and k, that is your vertex. Okay? So what that means is I can identify the vertex from vertex form simply by taking the opposite of whatever number's in the parentheses. See how this is a negative h, but our actual vertex is h? So the opposite of whatever this is, and the k is the same to get the vertex. Okay? Also, one more part of the question, which is a new term for us, called axis of symmetry. If you think about a graph, and if we had a quadratic that was like this, okay? And it has a vertex up here. We'll call this vertex 1, 3, okay, just as an example. The axis of symmetry is the vertical line that goes right down the middle of that function, causing it to be symmetrical. It cuts it right in half, allows it to be folded onto itself. Well, if you think about it, the axis of symmetry will always be the same value as the x value of your vertex. So if you know your vertex, you know that middle, either highest point or lowest point in your graph, and that is also the point of symmetry. And if you draw a vertical line through that point, that's called the axis of symmetry. And the shortcut is it's always going to be whatever the x value of your vertex is, that is your axis of symmetry. Let's see if we can use this information to answer questions 1 and 2. So for question number 1, if I'm asked to find the vertex, remember it is the opposite of whatever is in the parentheses near the x. So the x value of my vertex is a positive 5, and the k or the y value of my vertex is the same as this number on the outside, which is a 4. So that was much faster than graphing this and finding the max or min value. When it's in vertex form, it's really nice. Also, don't forget the axis of symmetry. Sometimes it's written as AOS. That's the vertical line that goes right down the middle of your quadratic. It will also go right through the x value of your vertex. So in this case, our axis of symmetry is 5. Let's try example 2. To identify the vertex, it'll be the opposite of this number in the parentheses, which is a negative 6. It'll be the same y value as what's on the outside, which is a minus 1. So there's the vertex of my parabola or quadratic. And the axis of symmetry will always be the same as the x value of the vertex. On this slide, it says convert from vertex form to standard form. Sometimes you're asked to rearrange formulas and functions for different meanings to serve different purposes. So in this case, we're given it in vertex form. We need to convert it to standard form. So we're going to expand this out, distribute and combine some like terms to put it in standard form. So the first step here is I'm going to take care of this x minus 5 squared by writing x minus 5 twice. Okay, that's the meaning of squaring something. Now, I'm going to simplify that. I'm going to distribute this x to both terms. So I'm going to bring all this down, bring down this 3 out front, and I'm going to take care of this part first. X times x is x squared. X times that negative 5 is negative 5x. Don't forget to come back and distribute this negative 5 to both of those terms also, giving me another negative 5x. Negative 5 times negative 5 is positive 25. And then bring down the plus 4 that was on the outside. We have some like terms that we can combine in the parentheses, giving me x squared minus 10x plus 25 equals 4. I'm sorry, it's not equals 4, it is plus 4. So now I can take this 3, that's the coefficient, and distribute it to all 3 of those terms in the parentheses, giving me 3x squared minus 30x plus 75, bring down the plus 4, And then one last step to have this in standard form is to combine my like terms. So now I have 3x squared minus 30x. 75 plus 4 is 79. I know it seems like a lot of steps, but we've learned every one of these steps in previous lessons. We know what squared means, so we wrote that factor twice. We distributed. Some teachers teach this by saying FOIL, first, outer, inner, last. After that, we combine some like terms. We've done the distributive property many times before, and then we also just combine those like terms at the end. Now this is in standard form. A is 3, B is negative 30, and C is a positive 79. All right, thanks for watching, and hope this helps.